Welcome to Chapter 12, Section 6, called Surface Areas and Volumes of Spheres. This is for Integrated Math 2 or IM2. So I'm going to be reusing some of these videos from a previous video, so the problem numbers may not quite match up, although you will see a title at the bottom to let you know which number it's supposed to be. It's just kind of a time saver there. Alright, so just to get started here, on the front screen, the first thing you should see is your due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. We always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. And partial credit is enabled, so if you answer one of two questions correctly, you get credit for the one question, or however many you answered correctly. This also, if I understand correctly, goes into parts of a question too. If there's more than one answer within the question, there's partial on there too. Down here it says, please remember, once you start your homework, you must finish it before you can work on anything else. And what that means is once I click start, down here in the bottom right corner, there's going to be a submit assignment button. This is how we finish an assignment. So what that means on the last screen is you can't work on anything because Alex is going to lock all of your other assignments and even the resources until you click the submit assignment button. What it's trying to do is leave this attempt open for you and not close it. If you say close this screen and you're not done yet, or you close your computer, it's trying to leave the attempt open for you. So just make sure that when you want to leave this screen, whether or not you finished, you click submit assignment so that Alex doesn't lock out all of your other assignments and resources. That's one huge reason to click that button. Another big one is that it actually affects the grade book when you click that button, so that your teacher can see what you've been working on, and hopefully it will improve your grade there. All right, on the side we always have three resources. We have explanation. Explanation tells us that we're going to lose our current question attempt because it's going to give us the answer to this exact problem. So it's not going to give you the answers unless you come type them in. Example will give you something very similar to what it is we're looking at and kind of walk you through the idea here. Make sure you read through background information, especially if you see this section. If you don't see the background information, it's kind of introducing something brand new. That's the idea. So you can scroll through. Once you're happy with that example, you can close it. You can open another example so that you can see another one worked through if you need to. You can also message your teacher directly from the screen so we know where to come help you, because it attaches a picture of this problem on the email. So it's a good way to get specific help on a problem. All right, let's go ahead and get started. All right, so we are looking at a problem that says the radius r of a sphere is 4.4 centimeters. Calculate the sphere's surface area A. Use the volume 3.14 for pi and round your answer to the nearest tenth. So this is definitely another example of background information. We would need to make sure that we knew the formula to calculate the volume of a sphere. If we don't know how to calculate the volume, then that's not going to work. Or surface area, sorry, I'm saying volume, but we're doing surface area first, then we're going to do volume on the next problem. So to calculate the surface area for any sphere, we go area equals 4 times pi times r squared. And they do a capital R for whatever reason in this formula. It just means the radius of the sphere. So lowercase r, capital R, when we're talking about circles or spheres, it's kind of the same deal. It's not necessarily changing anything. It's just that that's the way it was introduced in the problem. So they're using a capital R. So surface area, remember, that's the area on the outside. So the actual surface, if you were going to make a balloon, how much actual rubber would be used in that balloon, because you wouldn't calculate the amount of air inside the balloon for the cost of the rubber. It's just the outside that you're looking for, right? So that's kind of the idea we're looking for. Or even like a ball. Well, a ball is filled with air as well, or something else. It's not always air, but usually, we can picture like blowing up a beach ball, something like that. So if you want to calculate just the amount of kind of product used for something like that, that's what you would want to use surface area for. All right, so we're going to go area equals 4. They asked us to use 3.14 for pi. And the radius is 4.4. 4.4 centimeters squared. So we get to come over here and go 3.14 times 4, and I kind of wrote that in backwards, but that's okay. That's a commutative property. It doesn't matter how I write the multiplication because they're all being multiplied, so it's not going to change our answer. Equals, all right, it says, and round your answer to the nearest tenth. So the tenth would be the 1. That's one place after the decimal place. So I need to look at that next number. If it's 5 or bigger, then I need to round up. If it's 4 or smaller, that's when I round down, right? So I'm just going to put that guy in there. I don't need to worry about my units because it's already put in there for me. It's an area, so it's cubed. Because it's a little bit harder to picture in a sphere, but it's the idea of length times width. If we were to try to kind of cut this open and flatten it out, we want to know how much space it would take up on a flat surface. All right, next we are going to look at the volume of a sphere. So now it says the diameter D of a sphere is 9.6 centimeters. Calculate the sphere's volume, V. Use the 3.14 for pi and round your answer to the nearest tenth. Do not round any intermediate computations. So that means don't round until the end. If you round in the middle of a problem, it actually throws off the answer. Every time you round, it changes the end result. So they don't want you to do any rounding within. Again, we need to make sure that we know what the volume formula is. So with this one, it's a little bit different. When we did cones and pyramids, it was 1/3 the volume of either a rectangular prism or a cylinder. For a pyramid, it was a rectangular rectangular prism, and for a cylinder, it was a cone. But when we're talking about a sphere, it's a little bit of a different shape, right? So we have 4/3 pi r cubed. So we're actually cubing r, the radius. We're not going to square it this time. We're going to cube it. And this means we're multiplying by 4 and we're dividing by 3. So there's a little bit more to that one than just saying it's 1/3 of the kind of original shape or the whole shape. All right, so let's go ahead and put 4/3 times 3.14 times, and they don't give us the radius, do they? They give us the diameter, but remember diameter equals 2 radii. Because a diameter, if we're thinking about a circle again, diameter goes all the way across the circle. Well, radius goes from the center to the side, and a diameter just does that twice. So this is a radii and this is a radii. So if it's 9.6 for a diameter, I just simply have to divide that by 2, and that'll tell me what the radius is. So the radius of this is 4.8, and I can cube that. All right, so let's go ahead and type this in. 4/3 times 3.14 times 4.8 cubed. All right, let's go ahead and enter. And we do want to round down to the nearest tenth. So I'm going to go down to the tenth. Here's 0 is my tenth. The next number is 1. That's definitely 4 or smaller, so I'm just going to round it off. They do want to see the 0.0 on here. So basically it's Alex's way of seeing that you've acknowledged this rounding to the nearest tenth. If I try to do this without the 0, it's going to actually tell me, oh, it's not warning me. Normally it warns me on that one. So just, I guess that kind of depends on the problem there. But a lot of the time I've seen it warn me and say, don't forget to round to the nearest tenth if I leave off that 0.0. So interesting, it didn't do it to us this time. All right, so now we're going to look at a word problem. And a lot of the volume formulas do this, where we learn how to calculate the volume of a shape or a three-dimensional figure. And then on the next one, we have a word problem that applies that knowledge. So Evans Company makes solid balls out of scrap metal for various industrial uses. For one project, he makes copper balls that have a radius of 6 inches. If copper costs 75 cents per inch cubed, how much will the copper cost to make one ball? All right, so we need to know the volume of making one of these objects, right? We need to know the total volume. And then once I know the volume, how many cubic inches I'm using to make one ball, then I can multiply that by 75 cents because each one of those cubic inches costs me 75 cents. So we're going to apply our formula here and go 4/3 times 3.14, because they did tell us to use that in the very next sentence here, times, and they told us the radius is 6 cubed. All right, so let's come up here and let's go 4/3 times 3.14 times 6 cubed equals, so to make one of the copper balls, just one of them, it's going to be 904 32 inches cubed. Okay, so this is for one of, just to make one. And for each one of those inches cubed, it costs 75 cents. Oh, why is it beeping at me here? So I want to go times 0.075, because that, oops, 0.75. Help if I typed it in right, because it's each. All right, so it's going to cost $678.24. That's a pretty decent amount of money. All right. All right, so that was section 6. I will see you in section 7.